Okay, I think we are live. So my name is Sam Knight. I'm the Vice President of Product Management here at Blue Marble, and with me today is Scott Weber. Scott is the Product Manager for our GeoCalc calculator and Geographic Calculator Cloud lines.
Hello, everyone.
So today, this session is going to be focused on one of our newer tools, and that tool is the cloud version of our Geographic Calculator software. So Calculator has been around for a very long time. And this year we finally unveiled the cloud version of that. It's a new product for us, added on to the what folks may be familiar with in the desktop platform of Geographic Calculator. We added this to our line back in November 12th, and it's been out there. Folks are starting to use it. And this is going to be a session where we just talk a little bit about what is in the Geographic Cloud, Geographic Calculator Cloud, exactly how you access it, and all the bits and pieces you might be curious about. As we're going along, feel free to throw in any questions, and I believe Mariah is going to help us out with those at the end. So we're just going to shut off our camera here and get into our slides. So the main thing about Geographic Calculator Cloud is, what is it? What does it do? So it shares the name with our desktop platform. Geographic Calculator is essentially the tool that launched Blue Marble Geographics. So the desktop platform in various incarnations has been around for just about 30 years. And it's got a following for the things that it does, and the cloud platform is basically taking the utility of some of those features in the desktop, not everything, and we're going to talk about where those new functions are coming in. Taking some of those features and bringing them into the internet so you can access them anywhere in the world through a simple web browser. So the first thing is we say you can use it wherever you have an internet connection. So this is a browser-based tool. It is not, there's nothing to install with this. You simply go to the site of the calculator, and it loads up an interface that shouldn't be shockingly different to folks that are longtime users of the desktop platform. There are some changes, and we'll be kind of highlighting some of those as we talk along through our slides here. The way organization of users works is you basically are assigned a team of folks within your company. This is tied into your desktop licenses at this point. That may change in the future, but your team of users can sign on from any machine with just the order number that you have for your desktop platform at this point. And again, in the future, this may become a standalone offering. But when you are grouped by that order, it works exactly the same way as your desktop platform. By virtue of entering that order number, you are granted access if you have access to that with the purchases you've made. The main tools in the calculator are a subset of what is available in the desktop platform. This is a first iteration, and it will be growing, and we're hard at work right now on adding additional functions to the tool. There are three main areas of actual data conversion work. So all the typical geodetic conversions you might be expecting from the desktop platform. So in the cloud platform, we're calling those of you on the desktop familiarity will recognize the term interactive conversions. In the cloud platform, we're simply calling those point conversions. That's where we have one single numeric coordinate, and you're doing some type of operation on that. When we have many of those files, we're talking about tables and spreadsheets, whether those are something common like an Excel sheet or ASCII delimited text, that type of stuff. Those are going to be found on the point file job, and you'll see these represented as tabs across the top of the interface. And then finally, there is the vector file job, and that is also likewise familiar based on what we have in the desktop platform. These three jobs are really sort of the workhorses of the desktop platform. So what we started with in bringing this new code base to the web are the things that have sort of always been the longest, oldest bedrock features from the desktop platform, the ones that folks use day in and day out. This is added on top of our tool that we've had on the web for a number of years now called GeoCalc Online. And GeoCalc Online is basically a web repository, a database of coordinate systems. And it's the geodetic data source, all the parameters of the coordinate systems, transformations, units, ellipsoids, all of the geodetic parameters that live in the background of all the geodetic operations that we do in the desktop platform, in the SDKs, in any of our software. So the foundation of that side of the tool is found in the search tools within Geographic Calculator Cloud. So the search tools effectively replace what we have been hosting on our site as GeoCalc Online. So it is basically superseded and replaced by these tools. The searching abilities to go through the geodetic definitions, we can search in a number of ways. Things like name of a coordinate system or some definition entity. It doesn't have to just be coordinate systems. We can search by locations for things that are assigned locations like transformations, coordinate systems, and so on. Object types. So if you're looking for all of the parameters in the database, we call those objects. You can say look for a coordinate transformation, or you can look for a unit conversion, things like that. And then once you've found those things, you can make those portable. You can either directly link to them, or you can export them as, say, things like well-known text or geographic markup language files for portability to take those into other types of applications.
And the user interface for this search tool in Calculator Cloud is much more user-friendly, interactive design than the desktop version.
Okay, and then some bits just about how the service works itself. In terms of getting at your data, so the files that you're going to play with in this tool. Point conversions are simple numeric conversions, so those don't really need any data access. You simply type that into the coordinate fields for input, and you'll calculate your output. There's no files there. So the main two things are on the point file job and the vector file job. Point files, so this is where we're talking about things like basically spreadsheets of data, tabular structured data. Those can come from your local storage. And what that means is it simply comes from your computer. You upload it into the interface, and you choose what types of operations you're going to be working on, and you do that, and it gives it back to you in your local storage. Now, vector files, on the other hand, those can come from local storage, meaning you upload them just like point files, but you can also access vector files directly from Azure Cloud Storage if you have Azure Web Storage set up for your tables of any type of that vector data. So this is growing. Our first support for this is simply in the Azure cloud space, and we are looking at expanding that into some of the other cloud ecosystems as well. In terms of actually working with the data, spatial data comes in all sizes and shapes. It could be something simple like an Excel sheet with 20 pairs of coordinates on it, very light data, or it could be a gigabyte size vector file that has very heavy attribute tables, lots of finely detailed basically points, lines, and areas. And as such, how we handle those are going to be a little bit different. This does rely on cloud infrastructure to do the work in that type of mode. And there are essentially 3 virtual machine classes that are behind the scenes in here, and it depends on what sort of data you are putting up. If you're putting up something very light, the work might actually take place right in your browser, and it never even needs to go to the cloud. If you're doing something a little bit heavier, that's going to start spinning up virtual machines in the background to accommodate that file. And if you're doing something really heavy, it's going to spin up a very rugged, very CPU capable machine in the background to take on those much heavier tasks. So an example of that might be, say you have maybe a seismic layer It's very dense, very broad data, multi-gigabyte file, and you have that stored as a vector file on your Azure cloud storage. That's obviously going to take a much more rigorous process, and that would spin up the largest of the virtual machines in the background to accommodate that file. All of that happens behind the scenes based on the data that you're loading in. It doesn't actually have to be chosen up front. So how we figure out the costs in this, there's basically there's a sort of a formulation of how heavy the data is, how much processing time it takes, the size of the data, the bandwidth for upload and download, all of that sort of thing. That gets distilled down into what we're using inside here it's a credit system specific to this application. So for folks that are a Geographic Calculator user, you are going to have access to 100 free cloud credits per month with your desktop purchase. And it's simply something that it's there, it's available for you to use. You don't have to buy anything extra at this point. And that, again, that may change in the future. There may be some folks that only need access to the cloud portion, and we'll be developing that over time. These are based on annual plans. So if you have you start using the tool and you realize that this is a very useful thing for your deployment and your geodetic conversion needs, there are plans available that can up that to higher capacities if you're working with lots of heavy data and such, and those can be figured out fairly easily with some normal usage. Basically, you can see what it costs to actually take advantage of the conversions. Within this, there are 2-week evaluations available as well. So anybody can jump right in here, request an eval, and start using the site. The process is basically registering as a Blue Marble user on the website. So if you've done something like downloaded software from us before, or if you've registered with as a website user when licensing the software, if you're maybe part of a network license or something like that, you already have a Blue Marble user account. If you have not purchased anything from us, or if your particular username is not associated with an account here, you just need to register. It's a very simple process, like registering on anybody else's website. And then once you log in, there will be a request trial button. There are things you can do in there without registering, but all of the conversion tools do require you to sign in to get access to that full functionality. Obviously, there are going to be a lot of nuances here based on particular accounts, what company you're working for, and what type of licensing you have, and things like that. So if you have any questions about accessing the software and what is included with your regular calculator desktop purchasing, how you get access to that, feel free to contact our sales team. They'll get you set right up. It's a pretty easy process just to get folks associated with orders and get you on your way with checking out the tools. So let's take a little spin around the interface here. So again, we talked about how there's really effectively 4 places where you can do some work in here. We have the point file conversion, which is what we're looking at here. The point job, you'll see it's laid out a little bit differently than we do things on the desktop. And the reason for that is effective use of space in the browser. This application is set up to scale to many various different size screens. So even including things like tablets or mobile phones. When you are in a very narrow browser, you will see all of these fields and columns stack up vertically on top of each other. And so you have more of a top to bottom style workflow that you might pass through. The general workflow is exactly the same as it is in the desktop. So if you are familiar with setting up a coordinate conversion, involving a datum transformation and units and vertical coordinate systems and any pieces of that, all of the same pieces are going to be found here in this interface. The major difference is that the coordinate transformation box that we usually have right square in the middle of our interface in the desktop platform, you're going to see that down on the bottom left-hand side. So everything relating to your input coordinate system is going to be found on the left there with the source point conversion, all the way down, through the datum, the horizontal units, vertical coordinate systems, if you've got those in there, and the transformation to your output system, which is going to be over here on the target side, down on the right.
And note that the point job also does forward and inverse calculations, and that selection is found down in the transformation area.
And likewise, so these are all the same functions that we have available on the desktop platform. They're just simply now available to you from a web browser wherever you can take that web browser. So all of the same operations, the same left to right or right to left style workflow, allowing you to go back and forth if you're someone that likes to walk your coordinates left and right, as we hear from some surveyors tell us they like that sort of workflow. All of the same formatting options are available for units, everything from decimal degrees to the complicated formats of where the decimals and spacing don't go where they usually do, and so on. So all in all, it's a fairly simple place to work. The extra piece here that you'll see is that there's this little green area over here on the right where it says we're processing our files. That gives you a readout of everything you're doing. So that will show a list of the files you've converted if you're moving back and forth between tabs here, and so on. In the case of the point file job, it will display your output coordinates up at the top on the right-hand side for the target point here. And then also it's going to put those down in this status box. So that's the point conversion job. And next up, point file conversions. So all the same infrastructure is here again, and what we're talking about is how we set up conversions, more specific to tabularly laid out data. So in this example, we have just a simple Excel sheet, and it has some pairs of latitudes and longitudes in happens to be degrees, minutes, and seconds formats. And this is where you might start noticing a little bit different infrastructure from our desktop platform. Setting the columns for what your data, which is the input latitude, the input longitude, and where your outputs are going to go, and so on. That is done utilizing these drop downs at the top of each of these columns. And just like the desktop platform, any data that you have in there that is, just extra attribution or, whatever you might have in those other fields, all that just comes along for the ride. The only thing we need to actually interact with is where your coordinate columns are. And for those of you not familiar with the calculator, there is no required structure here. So the sheet that we have just happens to have longitude before latitude. They happen to be the first and second columns. They could be located anywhere in a very complex table. And it's not uncommon for folks to have multiple sets of coordinate pairs in different coordinate systems in this type environment. But the simplicity of the job is that anything that is not the operation you're doing just stays right where it is. So if we had multiple sets of coordinates in here, you would simply do whichever you wanted first. In this case, our geodetic latitudes and longitudes are the input for this particular example. We would write those out to another set of columns, and then you can go back and do whatever other operation you want to do and add more columns into the sheet. All of that behaves just like, oops, I'm scrolling through just accidentally hit the mouse wheel there. The coordinate system selection and all of that works exactly the same on all three of these jobs. And so you're going to notice a number of the familiar labels and things, and those are consistent throughout the application.
And this screenshot is clipping off the bottom of the interface where you have your transformation box, and this single point file job will also do the inverse and forward calculations if needed.
I think so. What I just did there was I habitually tried to scroll down using my mouse wheel. That was activating my slides instead. All right, next up is the vector file conversion job. And again, this is exactly analogous to the vector file conversion job in the desktop platform. You'll notice at the top left there where we upload our file for the conversion, we have that choice right there of whether we're going to be uploading from local data storage or cloud storage. If you do have access to that Azure web storage for your data. Obviously, the process for connecting to that is just going to involve hooking up your account information to get into that Azure storage. And local files is just going to be a conventional file upload, just like you would use for any other platform. The process here, again, mimics those other jobs. It's a very, very simple place to work. As you load your data in, it's going to give you a readout of the number of features in that particular data set, all the coordinate system information, if it contains, if the data itself contains a reference to what those coordinate systems are, it will automatically set your input for you. If it doesn't, then you just set it like you would in the desktop platform with an unknown coordinate system. Source and target does have some helper tools attached to it, just like the desktop platform as well. Because the coordinate system is identified and the spatial extents of it are baked right into that file. When we go to do our transformations, just like in the desktop platform, it's going to narrow down the list of possible transformations to get from your source data to your target data. And then over on the right, again, you'll see the little status field as that will be represented as it's converting, and give you a list of the jobs that you've completed basically as you're going across. Okay, and then so those are the three conversion jobs. And then next up, we'll take a look at some of the interfaces here for the search components. So the search, you'll find at the very top of the interface, there are two links up there. You'll see search distinct from the calculator. So if you click on the calculator tab, that is where you'll find access to those three conversion jobs. The search tool is basically taking you back to the style interface we had in GeoCalc Online, but this being the new platform for that. So the search basically takes place down on the left-hand side. In the search, you can search by things like EPSG codes, remarks, notes, the names of anything. And under the object type filters, you can specify exactly what type of parameters you're looking for. When we get our results, it's going to categorize those things depending on how many results come back, obviously. So this search was for the code 4326, which is a very well-known code for WGS84. And you'll see that it returns both things in the category of geodetic coordinate systems, but it also returns things in the datum transformations category because it is the target of some of those datum transformations or the source of some of those datum transformations. So we can expand down into those lists and drill all the way into the actual definitions where we can go further yet all the way inside and get at all the parameters. So again, just like the desktop platform, nothing in here is a black box. There are a few transformations and things like that that use extra grid files, but anything that is a mathematical parameter, projections, datum transformations, and so on, all of those things can be fully researched, fully exposed in the interface. And from that last step, once you're actually looking at these different things, you can take the step to export those as things like WKT or GML files. Any of the entities in here that have spatial extents attached to them, you'll see this is obviously a worldwide system, so you're going to see our red box on the map covering the entire globe. If you're looking at something smaller and regional, it will give you the representations of exactly where those particular parameters happen to live on the planet, and so on. So a number of fairly flexible tools in here allowing you to make the utility of the geographic calculator portable to you. So just to wrap this up and bring it all together, this basically allows you access to the geographic calculator from any computer, wherever you've got an internet connection. No downloadable software. It is simply all right in your browser. The main thrust of this is individual points, point files, so spreadsheets and vector files, plus the ability to access the full data source and browse through all of those parameters as well. Everything is cloud hosted. The database lives in the cloud of all of those systems. It is basically our primary source for publishing those for access in any of our software. You can get to your data both either locally from your local device, whatever that is, or directly from Azure cloud storage. And this is available to anyone that is a licensed user of the Geographic Calculator. And I think that about wraps us up right on time. And I believe Mariah is going to come on and help us with some questions.
Yes, hi. Thank you, Sam and Scott, for that overview of Geographic Calculator Cloud. And we can definitely kick off the Q&A session now. As a reminder to folks, we encourage you to ask questions. You'll be automatically entered for a chance to win a free license of Geographic Calculator. Um, so let's start with the first question. You did go over this just at the end there, but as clarification, is Geographic Calculator Cloud licensed separately from Global Mapper Pro?
Yes, that is a separate product. The access to the cloud tools is available to specifically Geographic Calculator users at this point. Anybody that is a Global Mapper user is very welcome to complete a trial, and we would love to have folks do that.
Mhm. Our next question, does Geographic Calculator or Geographic Calculator Cloud do grid to ground or ground to grid conversions?
So the coordinate conversions that we do in here are basically out of the geodetic data set that we have. So that's the collection of projections, geographic systems, some particular string-based coordinate systems, things like the Alberta Township system and so on. All of these systems are geodetically based. So for folks that are working with what we call best fit grids that are truly ground coordinate systems, that's not something we're going to find in here yet. But within the calculations of point files and the individual point conversions, the utilities are there to do those grid to ground calculations. So things like scale factors, convergences, and so on. So all of the same types of outputs that we have in the desktop platform are going to be available on the web platform. So some of the coordinate systems that are more of the custom user entered truly ground systems are yet to come in.
And we're going to be hearing a little bit about grid to ground work in our next presentation, I believe.
Yes.
Great, yeah. Our next question, is there support for the new state plan low distortion projections?
Okay, I don't think we've had a web session in the last 5 years where that question has not come up. It is the hot topic. So the new state plane coordinate systems, for those of you in other countries, within the next year, the United States is going to be getting a new set of state by state coordinate systems, and this will be replacing our current national standards. So every state is going to have new coordinate systems. Every state is going to have one statewide coverage. There's going to be a number of smaller zones in there. And then also there's going to be nearly full coverage of what we call low distortion projections, which are very localized and very, very low distortion from those types of grid to ground measurements. Those are currently in development by the National Geodetic Survey. This is, and I always joke that this has been a question that comes up for years because this is a very long project. It initially began as a 10-year project under NGS. They call it the National NSRS Modernization. And the outcome of that we're hoping to see at the end of this year. So while the new coordinate systems are not yet published, they don't exist as a standard yet. For years and years, we have been doing the preparation to be able to support those as soon as they are available. And that goes up to and including testing the individual zones in their provisional definitions as they exist now. I would say it's probably very likely that the person asking that question is familiar with the provisional publication of those on the NGS's beta website. And this represents about 1,000 new coordinate systems that will be joining our database, hopefully this year. While we don't put the provisional definitions in the software, basically to avoid confusion, we don't want there to be any room for errors from folks using incorrect parameters that may change this year. We are waiting to publish those when they are actually an official standard. We are basically lying in wait. As soon as they are published, we can most likely have them imported and available in about 5 minutes. Scott and I have been working on this for a long time. You got anything to add on this one?
Well, I was going to say that if you're interested in the method that the NSRS modernization low distortion projections are performed, I put together a 7 or 8 minute overview video that you can find on our YouTube channel, very quickly going over the whole procedure that they've implemented for creating these low distortion projections.
Mhm. Great. Our next question is, how is the cloud storage security protected?
So the cloud, everything that happens on our side is set up with basically with secure procedures. Everything is authenticated based on basically secure processes for your user account in the same way that your account is protected with your regular website account here. When we interface with Azure Cloud Storage, accessing your data that is in other cloud storage, that all basically uses the same user access keys that you would use to basically log into that system elsewhere. So it is all done with current best practices and so on. Any of the data that is entered in that is processed purely locally, it actually never even goes to the cloud. So there are a number of things that happen right in the browser, and the only data that does go to the cloud are those heavier things like vector files at this point.
And there's Azure has certain architectures that help ensure security, separating different functions from each other, and we're incorporating those.
Right. Okay, I will wrap it up after this last question. Have you worked with any of the states that have already switched to LDP, like Kansas?
Yes, so over the years, low distortion projections are not really new anymore. We've had them in there for a long time. So Kansas is actually one of the more recent states. I'm thinking of one I remember off the top of my head is Iowa. We actually directly worked with some folks that were vetting the parameters that they came up with to make sure that they were compatible with software. And I know those folks reached out to a number of different companies to work with. We did testing for that. We've been testing for all of the new standards. So we've actually loaded and verified every provisional publication of the new low distortion projections. Well, all of them, not even just the low distortion projections for the coming state planes. But states like, say, Minnesota, Wisconsin, some of the states that have had very long-standing low distortion projections, Oregon is another. We've had direct contact with many of those folks, and a lot of those are very mature coordinate systems. They're well established, and we've supported them for a very long time now.
And while low distortion projections aren't new in and of themselves, the method used for all of the NSRS 2022 projections, they all follow the same procedure, and it's more portable than some of the traditional methods that have been used in the past.
Great. Well, I think that's all the time we have for. Of course, we'd love to ask you more questions, but thank you again so much for that presentation.